Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Chelsea Jewell.
So thanks everybody for joining us today. For our session today, we're going to talk about the importance of drying, specifically in reference to electronic assemblies. So when we're talking about drying and why it's so important, it tends to be a critical factor that affects many things post-cleaning processing, especially in the storage of electronic assemblies. So what we're kind of going to go through today is some areas of concern and how to optimize that drying process to make it more efficient. So specifically in reference to this presentation, we're talking about post-rinsing, all of the chemistries off the board, and we're moving into the drying section with just water present on the surface. If you have any consideration or any concerns with rinsing, we recommend this two-part series that we did earlier this month, specifically on the importance of rinsing. So for the purpose of this, it's more post-rinsing going into your drying process. So kind of kicking things off, our areas of drying concerns when it comes to assemblies, when it comes to any type of shorting or electrochemical migration, the combination of electricity and water tends to be detrimental. So what we're going to look at is a little bit on conformal coatings, how that can be affected, electrochemical migration, corrosion at its core, and then wire bonding issues that you could potentially have. So looking into conformal coating, if we are seeing a couple different areas of failure with conformal coating, we can lean back into what's going on in that dryer section to kind of help figure out what's going on there. So delamination, kind of what you're seeing in this both of these images, is that coating is actually peeling up off of the surface of the board. This can be due to high moisture. There's a couple other areas it can happen, but drying is usually something that we kind of start that process to troubleshoot. So, poor wetting of components, you can see haziness in the conformal coating. All of these can lead to an indication that the board's not completely dry before the coating was applied. Looking at, vapor deposition applied coatings, that moisture, because they're applied in a vacuum, when it pulls that can potentially cause issues with the equipment. So, an understanding of a bakeout process or how, moisture can get trapped in the board is a good starting point to make sure everything's set up well before going into a coating process. Next is electrochemical migration. So when we're talking about failures on the boards, movement of ionic material across the board, moisture is a key indicator that there's a problem there. That can be either from moisture in the environment or moisture as you're coming out of the drying process. One of the key indicators we've seen is specifically with SIR, surface insulation resistance. If you look at these graphs, kind of the red line on the top chart and then the green line on the bottom one, how you're seeing that board start out as a hard failure and then recover. This is an instance that there was moisture trapped underneath the component. And while that area doesn't completely recover up into an acceptable level, there is a noticeable shift where it's coming back into back out online there. So looking at troubleshooting your drying process, an SIR test may be a really good piece, a really good test to be able to flesh out what you're doing there. Larger packaged components, they tend to have specific challenges with this. If you're looking at vented components, getting moisture in there in any aqueous process isn't a problem. It's how to get it back out and how to ensure that as you go on to your post cleaning processes, that's a reliable component. You can look at um, covering those, masking those materials. We've also seen some instances with like an IPA rinse. That's an option prior to a post bake out process. But All of these factors can play into electrochemical migration and issues that you're seeing growth on the surface of the boards. The other issue is corrosion. It's fairly common that we see, inductors or other materials that have ferrous components. When you combine any type of moisture and ferrous components exposed to that atmosphere, this corrosion can present. Storage conditions are a key factor in this. So if that board isn't completely dry, like free of moisture, and cooled back to room temperature, if you're bringing them out and packaging them up, even so much as flipping the ESD bag over and putting a label on it, you can still create pretty much a humidity chamber inside that bag if there's any type of moisture present. So when you're looking at longer term storage for these materials, if you're looking at long-term shipping for these materials, if you have created a more humid environment from that board that is at an elevated temperature and there's any moisture present on it, by the time those boards have arrived where they're going, it's very common to see this type of corrosion present on anything that has ferrous qualities. Um, you know, some considerations with that, what we like to say is make sure that those assemblies are back to room temperature before packaging. The moisture indicator strips are great. Desk kit bags are great for this, but in reference to specifically the drying and the cleaning process, you want to look to make sure that there's no excess moisture on the board before any packaging occurs. Also looking at advanced packaging, mostly what we've talked about thus far has been, PCB, but when you get into advanced packaging, the quality of bond and the complication level there is so much higher. So when you look at these surfaces, high temperatures during a drying process, you can definitely cause oxidation on the surface, and that's going to impact your wire bonding. There's an appearance factor. You can look in our copper DBC in this image. What they've done is they've done a really, really high heat drying, and it's flashed that water on the surface to the point that you're getting a pattern oxidation as it's going through the cleaning process. So this is going to impact how everything bonds onto that surface in subsequent processes. So what we like to say is while higher temperature tends to be where people will lean towards, understand how that higher temperature can affect your material set as well. Anything copper related, the nickel DBCs, those high temperatures can affect detrimentally. So understanding how much heat you're actually putting into the process. Also looking at how your air knives are oriented. You want those air knives to be able to sheet material and water off the surface in a relatively uniform pattern, so you don't have that pooling situation that's happening with the copper. Another, indicator that drawing isn't efficient is fixturing marks. So on our nickel DBC, we're seeing little rectangles that are showing patterns after the drying process. So what we're seeing here is there's moisture trapped between the fixture and the surface of the board that's causing this pattern discoloration. So understanding more, going back to those air knives, how is it moving water off? Are you pooling moisture there in between that fixture and the DBC, and it's creating that oxidation type environment, or is it free flowing and able to be blown directly out of it? So those are some considerations that we would look into if you were seeing drying marks or pattern oxidation type materials on these type of assemblies. So looking at process considerations, because now that we've kind of identified possible issues that we can see after the drying process, we want to fix it, of course. So specifically, some considerations if you're in a batch system, look at the direction of your connectors. If they are sitting upright in that batch washer, it may be difficult to fully drain that component. So if you're just sitting there pooling rinse fluid, it can be somewhat difficult in a batch scenario to fully push that water out of there. So what we try to say is, if you can, position those connectors to where they're facing downwards so you don't have that cupping action on the top of the board. You Obviously, connectors can be on multiple edges of the board, multiple places on the board. Understanding how that board looks in the machine to prevent that cupping action. If it is unavoidable, I've seen multiple connectors that are designed specifically to help with drainage, whether that's uh, notches on the side or it's not fully sealed at the bottom. It depends on what type of connector you're using, but some considerations to help promote drainage can help very much so, making sure you have an efficient drying process in the machine. So if that's not really an option, you look at post-processing bakeout. This is something I feel is very common in the industry, especially if you're going into any type of conformal coating. But understanding, there's some steps that you can take in the machine to help reduce the length of time of that bakeout in post-processing. We mentioned earlier for those lidded components, that it's very easy to get fluid into those. It's somewhat more difficult to fully dry them out. So what we've implemented occasionally is an IPA water rinse prior to a bakeout process. So what that's doing is it's allowing the IPA water combination to displace your rinse fluid and then promote drying once you go into a bakeout process. It will reduce the overall bakeout time because you're not just focusing on the water in a very closed off environment. Typically, we're looking at a bakeout that's more in the hour range than the multi-hour range is what we're seeing with that. And that can be implemented not just for lidded components, but for large packages that you're seeing water pooling underneath it. That IPA can help displace some of those materials and help with drying. So kind of in summary, drying is a critical factor that we have to consider. We put a spotlight on the wash zone. We really, really feel strongly about our rinse, but I feel like the drying part of the process is just as critical. So looking into kind of some key indicators that might show you're having drying issues is kind of what we've gone through today. And I would recommend looking at your process if you're having any of those issues and seeing, do we need to shift the direction of our board? Do we need to look at our air knives? Do we need to look at our fixtures? Are our fixtures creating a drying issue as well? So understanding how that all is set up, those factors that go into your drying process is a great kind of first step to troubleshooting some of those issues. And then, looking at a post-process bakeout that may be necessary for very complex assemblies. The IPA is a great method. IPA water combination is a great method to look at. Shortening that bakeout is what we've seen. So kind of rolling into some frequently asked questions when it comes to drying. So understanding how when a bakeout is required, understanding that. So, if you are running heavy production and you cannot slow that down, you cannot extend your drying time, that is when we start to look at is a bakeout the best method rather than slowing the whole cleaning process down. We can take this offline and run that in batches to get to production quality or production levels. Another thing we see is a very, very complex components. You just making sure they're super critical in getting those dried out. Those are the things we tend to look for a post-process bakeout. As far as bakeout times and temperatures, it really depends on what materials you have on your board. So if we're talking about the copper DVCs, you don't want to take them to extreme temperatures because that can induce oxidation on the surface, which inhibits other post-processing steps. typically with PCBs, we're normally trying to get at least 100 C. You want to be close to the boiling point of water for an effective bakeout. Times, it's going to depend on how complex is this board. Are we just trying to get some connectors dry? Are we trying to get a large component, a large BGA dry? Those are some factors to look at with there. I've done testing to where we've taken like an air nozzle and seen how much water drives out underneath it, looking into your moisture indicator strips to see if once I have that board packaged up, is it showing up on that moisture indicator strip? So those are a couple options that we look at in building out common times. But normally it will be between an hour to 4 hours at least 100 C is what we're looking at, depending on how complex your board is. So knowing if your drying process is effective. Well, first and foremost, are the boards coming out of the machine dry? Are you seeing pooling in any sections of the board, any complex geometry that's holding water? An air knife or just an air nozzle is a great tool to be able to force air underneath components and drive it out. A lot of times what I look for is just that initial kind of spray pattern that will go across the surface from underneath components, from out of connectors. That type of application we kind of use to troubleshoot. Do we need to help slow this process down because I have it in this component, or are we having a fixturing issue to where that water is really, you see it drive out from the actual fixture rather than just the assembly. So as far as failures that would indicate drying issues in long-term storage, overall, what we see is corrosion on the surface. You see that once everything's powered up, some electrochemical migration, that's a little bit longer term reveal, but mostly it's surface corrosion that we're seeing after drying issues. But yeah, so thank you all for your time today, and I hope this was helpful.
Thanks, Chelsea. Thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.